Okay, so your transformations you should already be pretty familiar with. The only ones I think are new are two of them, which is my reflection over the y-axis and horizontal stretch and shrink. I don't think we do that with parabolas, but everything else we should have done with parabolas, with your quadratics in chapter 4. Okay? So I'm still going to go over this table. Remember, a transformation is anything other than the parent function. So a translation, a stretch or shrink, a reflection, anything like that would be a transformation. So if you have something inside parentheses, whether it's a translation, stretch or shrink, or a reflection, it's always the opposite of. Okay? Everything with your x is the opposite of what you would read. I always say x is a liar. So if I have x minus a number, it's the opposite direction. You're really going right that many units. Okay, if you have x plus a number, you're really going to the left that many units. Okay, that you should be familiar with because I know we did that with quadratics. If you have a plus or minus behind your f of x, so if I have f of x is equal to x cubed, and then I have x cubed plus 1, that's as straightforward as you can get. The direction it goes with your sign, and the number of units is with that. So x cubed plus 1 is up 1, x cubed minus 4 is down 4. Okay, so outside of the parentheses is straightforward. Inside, x is a liar. Okay? Your reflections, if you don't have those down, that would be one of the things you have to memorize, that and horizontal stretch and shrinks. Your reflections are really the opposite of the variable it affects. Okay, so if you want to visualize that, if you have your x and y axis, and I have this point right here, and say it's 1, 2. I can't see that. I'll move this. If you have a point 1, 2, and I want to make the x value negative, that's what f of negative x is. I make this x value negative, it becomes negative 1, but my y stays the same. Well, I made the x negative, but what axis did it flip over? The y. Okay, so that's what I say is it's going to flip over the opposite variable. If you have, if you have negative f of x, remember f of x is the same as y. So if I have that same point 1, 2, but I make my y negative, that becomes 1, negative 2. Oh, that's supposed to be a 1. We're going to just erase that, or scratch through. 1, negative 2. Okay, so I made the y negative, but I flipped over the x-axis. Okay, so those axes are going to be totally different than what it shows. Okay, so you got to be careful when you're writing. When you tell me it's a reflection over the blank axis, make sure you're paying attention to that. Okay. Now your horizontal stretch or shrink, that is new. If you know x is a liar, then it's the opposite stretch or shrink than you would think with vertical. Okay. Vertical, we knew if that number was greater than 1, it was a stretch. If it was a fraction less than 1, we knew it was a shrink. Okay, y'all remember that? So horizontal is different. If I have more than 1, it would be your first instinct to say that it's a stretch by a factor of 2, but it's the opposite. You're really having a shrink by the reciprocal. So if I have a 2 inside parentheses, I'm really doing a 1/2 times my x values. Okay? If I have a 1/2, that's not a shrink. That's the opposite. It's a stretch by a factor of its reciprocal, which is 2. Okay? This is just reiterating anything outside the parentheses affects your y's, anything on the inside affects your x, and it's always the opposite of. Okay, now an inflection point, we briefly talked about this before. That is the point where the graph, we said changes directions, but the pre-cal teachers want y'all getting in the habit of, instead of saying direction, saying concavity, because that's the proper term. So the point where the graph changes concavity, and all that means is direction. So we knew that if you have a positive leading coefficient, something opens in the positive direction, right? Your end behavior ends in the positive direction. You have certain parts of your graph, and we always say, like, it opens up. Think about quadratics. We either opened up or we opened down. Opens up, technically the term should be concave up. If it opens down, the term should be concave down. So that change in direction is your concavity. Now, if you're just looking at a graph, this is where the graph flattens out. That's all you're really looking at, and it's going to be at the center of your graph and table. Okay, so our first three examples, all we're doing is describing the transformation. Okay, so if I have f of x equals x cubed, that is my parent function. Anything other than x cubed is a transformation. So I'm going to box in my x cubed. Any other number tells me I'm doing something, okay? If f of x is x cubed, then I have x cubed minus 3. It is not in parentheses. I have no parentheses, so it's affecting my y value. So if I have a minus in the y direction, I'm shifting that where? It shifts down 3 units. You can do shifts or translates. Shifts is just shorter. Same thing. Translates is more mathematical, but I'm good with shifts. Alright, the next example, my parent function is x to the 5th. So here, I've got x minus 2 in parentheses to the 5th power, and then I have a plus 3. So if it's happening inside my parentheses, it's happening to my x, and it's the opposite of. So where is that going to shift? It's going to shift right 2 units, and that plus 3 tells me it goes where? Up 3 units. Y'all good with that? So my parent function is x cubed. Now I have a 2 in front of my parentheses, and inside parentheses I have an x plus 1. So what does this 2 tell me? Is it happening to my x or my y? It's on the outside of parentheses, so it's my y. So it's a vertical. Whatever it is, it's vertical. You have to emphasize if it's a stretch or shrink, if it's vertical or horizontal. Okay? Now this number is more than 1, so it's going to be a vertical stretch by a factor of 2. So whatever that number is, that's your factor that you would be multiplying by. Okay? And then that plus 1 is happening inside parentheses, so it's happening to my x. So that tells me I'm shifting where? My x-axis goes left and right. It's the opposite of, so it shifts left 1 unit. Okay? Are you okay with that? Alright. Now for our graphs. I give you a parent function and I give you the transformation, and then we are going to build, the first step is always parent function. We're going to build your parent function table and graph your parent function, and then we look at the transformation. So for your parent function, whether it's x cubed, x squared, x to the 5th, x to the 20th, okay, we're going to use the same x values, -2, -1, 0, 1, 2. And then the way you find your y values for that is just taking that specific x value and plugging it into your x cubed. So if you need to do that in your calculator, make sure you put your value in parentheses so you don't mess anything up. Okay, so -2 raised to the 3rd power should give you -8. -1 to the 3rd power should give you -1. 0 to the 3rd power is 0. 1 to the 3rd power is 1. and 2 to the third power is 8. Okay, so all I did was I took these x values and I plugged it in for my parent function x value. Okay, and then I'm going to graph that. And my inflection point is the center of that graph, which is the center of our table. So my parent function inflection point is 0, 0. Now, to build your transformation table, we're going to build our headers. So we're going to look at our function x cubed minus 4. Did anything happen inside parentheses with my x? No, there's no parentheses, so my x stays the same. So I'm going to copy the x values from my parent function over to my transformation. -2, -1, 0, 1, 2. I'm almost positive we did this with quadratics, but I can't remember if we used the graphing calculator or built the tables. But I think we did this. So here, x cubed is my parent. This minus 4, it's not in parentheses, so it's happening to my y. So I'm doing y minus 4 in my table. So what I'm doing is I'm taking each y value from my parent function and I'm subtracting 4. So I take -8 minus 4, and that gives me -12. I take -1 minus 4, which gives me -5. 0 minus 4 is -4. 1 minus 4 is -3. And 8 minus 4 is a positive 4. Okay, and then we're gonna graph that. What's my new inflection point? 0, 0 changed to 0, -4. So my instructions say I need to state that. And your inflection points only happen with odd functions. Okay? Now, my only transformation I had was what? Shifts down 4 units. Y'all good with that? Yes, ma'am.
How did you get the y values in the first table again?
You take -2 and plug it into your parent function.
Oh, okay, got it.
So any way you build a table, whether it's x squared, x cubed, x to the 5th, anything, that's you use those -2 all the way down to 2, and then you plug that into your parent. Okay, I want to give y'all time to do your worksheet, so we're going to just build. This one is just translations. I want to hit a stretch or shrink first before we move on, but I think y'all can handle translations, but I want to build the transformation table. So if I had x plus 5 cubed plus 2, what would my header be for my x?
X plus 5? X minus 5.
X minus 5. Remember, it's the opposite of, so you would do x minus 5 and then y plus 2. Y'all understand how you would build that? Okay, we're going to skip that if y'all are okay with skipping that, because I've got other examples that I want to show you. Okay, so here, my parent function is still x cubed, so -2, -1, 0, 1, 2. I'm I'm taking those and plugging them into my x value for my parent function. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 is 0. 1 cubed is 1. 2 cubed is a positive 8. Okay, and once you graph that, look at your new function. 4 times x plus 2 cubed. What is happening to my x? I have an x plus 2 in my function, so in my table, what should I have? X minus 2. It's the opposite of. And then whatever is outside my parentheses happens to my y. 4 is being multiplied by that, so I'm going to have a 4y. Okay, so I'm going to take my x values. Negative 2 minus 2 gives me negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. Okay, now I'm going to take all of my y values and multiply them by 4. So if I have negative 8 times 4, what does that give me? Negative 32. Negative 1 times 4 is negative 4. 0 times 4 is 0. 1 times 4 is 4. And 8 times 4 is a positive 32. Obviously, 32 is not going to fit on my graph, but that shows you how high you need to go for those x values, so you should not be crossing and making your graph wide. Okay? So I'm going to plot my negative 3, negative 4, negative 2, 0, negative 1, positive 4. And I'm going to make that a very straight upward line going forward. And then what would my new inflection point be? If it's the center of your graph, the center of your table, it'd be negative 2, 0. With evens, with quadratics, we always said it was the vertex, and that was the center of your table. So it's similar to that, okay, the location-wise. All right, I had 2 transformations. The 4 told me I had a what? It happened to my y, so that's a vertical, it's a greater than 1, so it's a vertical stretch by a factor of 4. Once you get in the habit of doing by a factor of, because in pre-cal you will do that when you do transformations. And then the x minus 2 told me I shift left 2 units. Y'all good with that? Alright. The last graph we're going to do, we have x to the 5th instead of x cubed. So I'm still going to do negative 2, negative 1, 0, 1, 2. But now I'm going to take negative 2 and raise it to the 5th power. So negative 2 to the 5th should be, you all have a calculator, negative 32. Negative 1 to the 5th stays negative 1. 0 to the 5th is 0. 1 to the 5th is 1. 2 to the 5th is now a positive 32. Again, 32 won't fit on my graph, but it shows you just how high it's going. So don't make, when you go to graph this, don't make it go all the way over here if you know 2, negative 32 should be all the way up here. Okay? Okay, on my transformation function, I have parentheses, but there's nothing going on inside those parentheses. So do not let that mix you up, okay? Nothing is being added or subtracted or multiplied, so my x's stay the same. They're going to stay -2, -1, 0, 1, 2. But my y's, what's going to happen to my y's? I have an 1/2 times y, but then when I'm done with that, I have to subtract my 3. Y'all understand how I got that?
Yeah.
Okay. So -32, you're going to do order of operations. Times 1/2 is a -16. -16 minus 3 is going to give me, thank you. -1 times 1/2 is a -0.5. You can do decimals. I'm okay with it at this point. Okay. It's a -0.5 minus 3 is a -3.5. 0 times 1/2 is 0 minus 3 is a -3. 1 times 1/2 is 0.5. Now you have a positive 0.5 minus 3. That's a -2.5. And then I have a 32 times 1/2, which is 16. 16 minus 3 is 13. So I'm going to plot my -1, -3.5, 0, -3, 1, -2.5. 2, 13. If this is 11, 12, 13 just looks like it's up there. -18, I'm not going to try to do. Make sure you put your arrows. My new inflection point will be what?
0, -3.
And I had 2 transformations. I have a 1/2 y. It's happening to my y, so I know it's vertical, but is it a stretch or a shrink?
A shrink is less than 1.
It's a fraction, so vertical shrink. Remember that if you would have had a negative, that has nothing to do with stretch or shrink. Negative only tells you what?
It reflects.
A reflection. Okay, and then the -3 for my y tells me it shifts down 3 units. Okay? Do we have questions on our graphs? So now what I give you is I give you a full function for f of x. And then g of x, I give you a rule on what your transformation is. We need to figure out what is that transformation, and we need to get our new function according to that transformation. Okay? So if my function is f of x equals x cubed plus x squared plus 1. And this is telling me my rule is g of x is equal to f of negative x. This right here is my transformation. f of negative x, the moment I see a negative, I know it's a reflection. Okay? I'm making my x's negative, so that reflects over what axis? The opposite reflects over the y-axis, right? Because remember when I drew that, if I have this point, but I make my x negative, it goes to the left, I'm flipping over the y-axis. So if you need to draw that to visualize it, you can. Okay? Now I need to come up with my new function. So this f of negative x tells me everywhere there is an x, I'm replacing it with negative x. Okay, so g of x will equal, replace x with negative x cubed, plus replace x with negative x squared, plus 1. So if I take a negative raised to an odd, that stays negative. Y'all remember my pattern? Odd opposite. So that stays a negative x cubed. But if I take a negative raised to an even, that stays positive. So negative x times negative x is a positive x squared. And then I bring down my plus 1. And that's my new function. Okay, so now I have f of x equals x cubed plus 2, and g of x equals 3 times f of x minus 1. So my transformation rule is right here. That 3 times f of x tells me, is it happening to x or y? It's happening to y. It's not in parentheses. So that would be a vertical. It's greater than 1, so vertical stretch by a factor of 3. And then that minus 1 tells me I'm shifting where? Shifts down 1 unit. So how do I build my new function if I have two transformations? Okay? I'm taking my f of x and I'm multiplying it by 3, and then I subtract my 1 according to order of operations, right? So this x cubed plus 2 is my f of x. So g of x, which is my new function, I have 3 on the outside, and in parentheses, I put my entire function. Okay, so I'm going to put x cubed plus 2, and then minus 1 on the outside. We're good with that? Okay. So how am I going to multiply this by 3? All I'm going to do is distribute. So g of x is equal to 3x cubed plus 6 minus 1. And then what's 6 minus 1? So my function is g of x equals 3x cubed plus 5. Are y'all okay so far? Okay. So now I have f of x equals x to the 5th plus 5, and my g of x is f of x plus 1. This time it's happening inside my parentheses, so it's happening to x and is the opposite of. Anytime I have a plus or minus, I know I'm shifting. I just have to figure out where. Opposite of tells me I'm shifting left 1 unit. So if x plus 1 is inside parentheses, you treat it like you did this negative x. Whatever is inside parentheses is what I'm changing my x to. So g of x is equal to, replace x with x plus 1. That's raised to the 5th power plus 5. I am okay with it saying just like this. There's no point in taking x plus 1, writing it 5 times, and multiplying it 5 times. I'm not going to make you do that. Okay, so if you just have something simple like this, leave it just like that. Okay? I'm okay with that. Now y'all attempt number 4. Try to do that one. And we'll check. What does the negative tell me in negative 1/3 f of x? The moment you see a negative, you should automatically think reflex. Now, is it happening to my x or y? It's happening to my y, so it reflects over the opposite axis, so my x-axis. Okay? And then this 1/3, it's happening to my y, so it's a vertical. Vertical what? Stretch or shrink? Shrink by a factor of 1/3. Okay, now when you go and do your function, you're taking your entire function, f of x, and multiplying it by negative 1/3. So I've got a negative 1/3 times x cubed plus x squared plus 1. And all I do is distribute that. Okay, so g of x should equal negative 1/3 x cubed, negative 1/3 x squared, minus 1/3. Y'all good with that? Okay. You're not going to have a quiz over this. You are done with quizzes. Next class will be review, and then the next will be a test. So Friday will be y'all's test.
Is it our 6 weeks test or?
That'll just be your 5-5 through 5-8 test.
So we have that and then the 6 weeks test?
So then, So then the following Tuesday, next Tuesday, will be all 6 weeks review. We'll figure out if you have to take the 6 weeks test or not. Remember, if you make lower than a 75 on either or both chapter tests, you have to take the 6 weeks test. Okay? And then 6 weeks test will be next Thursday. So test this Friday, test next Thursday.